All right, schedule-wise, we're down to the last 2 weeks. So Thanksgiving is all here. Okay, so just 2 weeks left. Um, I don't have that much material left, so we're probably going to finish most days early, um, including today. So I think we're right on schedule. 6-3, a couple days for that. 6-4, a couple days on that. 6-7, a couple days of that. Okay, so again, we're aiming for next Thursday, the 10th, for the last regular test. Okay, and so what's going to happen Friday, the 11th? Let's just make that a review for the final exam. Okay, in fact, it would not be a bad idea to start reviewing for the final exam now, since I'm kind of slowing down the material. So, and that's partly by design. I slow down the amount of new material so you can go back and review the old material. Okay, to study for the final exam, just review the old exams, okay, because I'll pick problems from old exams for the final exam in all likelihood. Okay, so go back and whip out the first test and the second test and the third test and the fourth test, right? And the fifth test, you've got them all, and start reviewing those as I give you new material. Okay, so let's say Friday the 11th, there'll just be a Q&A session, question and answers on previous exams. Okay, and then all we have left is the final exam, which is Monday the 14th, which is very close. In fact, that's what? That's 2 weeks from today, I think it is. Yeah, 2 weeks from today. It's all over, folks. So notice the starting time, 8:10 to 10:40. You have 2.5 hours to do the final exam. And most of the final exam will be questions that are just like, the previous exams. And then that's about it. Okay. So that's where we're at. Reminder of the assignment for 6-3, I'm changing to 1 to 27 odd. Okay, so I was going to do half or a little bit more than half today and the rest tomorrow. And then 2 days for the hyperbola, maybe longer. Okay, we'll get our last quiz on Friday. Let's see. Yeah, this coming Friday the 4th will be our last quiz. Okay, so this is on the ellipse. I'll be doing ellipses today and tomorrow. Hyperbola is Wednesday and Thursday. Okay, then we have something called parametric equations. Okay. So the quiz this coming Friday will most likely be on ellipses and hyperbolas. I haven't decided yet, but I'll let you know by Thursday. Okay, and speaking of quizzes, so the quiz is now too late to submit, of course. So okay, to give us the focus is at -1, 3. The vertex is -4, 3. I know the focus is always on the inside of the curve, so I know it's going to open to the right. Okay? If it opens to the right, it's of the nature of y squared equals 4px. The p is the distance from the focus to the vertex, so that's 3 units. So the p is 3. So if my vertex were not translated, I did not move it off the origin, then it would be y squared equals 4p, which is 3x, or y squared equals 12x. However, since the vertex is -4, 3, 0, 0, the vertex got translated to -4, 3, so it should be y minus 3 squared equals 12 times parentheses x plus 4. Okay, and if I go 3 units to the left, that gives me x equals -7 for the directrix. Okay, again, if it's not good enough for you to just say -7, you have to say x equals -7. Okay, and again, on a lot of your quizzes, I was much more forgiving than I might be on exams. So I might say, okay, change this or try this or whatever. Okay, so I'm a lot more lenient on quizzes than exams. So make sure you catch that. For the directrix, it's got to be x equals blah, 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 or y equals blah, blah, blah. Okay, so y minus 3 squared equals 12 times x plus 4. Okay, the second one, they're already giving me this. So squared in x, not in y, and a negative means it's going to go down. Okay, so right from here, the vertex is at 4, -2. You force the -16 to look like -4p. So -4p is -16. That means p is equal to 4. Okay, that if I plug in a 4 to the formula of -4p, right? It looks like this, -4 times 4. Okay, so it's 4 units from the vertex, which is 4, -2. This tells me it's opening down, so I go 4 units down to get the focus, which is 4, -6. And I go 4 units up to get the directrix. Again, the directrix, you have to write y equals 2, not just 2, y equals 2. And that's the way that should look like. Okay, so that should pretty much do it for the quiz. All right. Okay, so that's about it. And we'll get started on the ellipse now. So I just gave you a lot of theory last time on the ellipse. Let's just hit the highlights before doing some problems. And we'll probably finish early all the rest of our days. So for the ellipse, page 328, okay, there are two foci. Okay, they're always along the major axis, the longer side. Okay, so x squared over a squared plus y squared over b squared equals 1. That's the standard form of the ellipse. Okay, I'm not really going to use this. I'm still going to leave it like that. I'm going to switch around the a and b. A is the larger number, b is the smaller number. Okay, so if the larger number is under the x, it's bloated, so to speak. It's bulging in the x direction. Okay, if the larger number is underneath the y, then it's bulging in the y direction. That's easy, right? Larger number with x, so it's bulging in the x direction. Larger number with y, it's bulging in the y direction. Okay, so a tells you how much you move left and right. So notice x squared over a squared, you take the square root of a squared, so it's a. So from the center, you go a units left and right. You go b units up and down. Okay. All right. So that's what happens there. And we have the Pythagorean relation. The book doesn't have it, but it's equivalent to what the book has. I write it as a squared equals b squared plus c squared. What they have is correct, but I think it's easier if you do it the way that I showed you. Okay. So here we go. So I was just going to go up to maybe 13 or 15 today and save the rest tomorrow. Okay, so sketch the graph of the ellipse showing vertices and foci, focal points, foci. So the vertices are the endpoints of the major axis, okay, and the foci are always along the major axis also. Okay. The endpoints of the minor axis aren't called anything. All right, so you have to get the equation in standard form, which means x squared divided by something plus y squared divided by something equals 1. This one you can just say divided by 1. Okay. And let's say for number 5 or 7, the right-hand side isn't 1, so you make it a 1. Like for number 5, you would divide by 400. For 7, you would divide by 6. And these are a little harder. You're going to have to complete the square. So I'll show you how those work. Okay, so here we go. Okay, so number 1, page 234. The book goes, again, x squared over 4 plus y squared, but treat it as y squared over 1. It's got to be over something in your standard forms. So let me show that to you again quickly, please. Yeah, x squared over a squared plus y squared over b squared. So if you don't see anything there, then just pretend it's over 1. Right? So in the original question, it just says y squared, right? It just put y squared divided by 1, which is what I did over here, as you can see. Where'd it go? Okay, so take the square root of this, that's your a is 2. Square root of 1 is 1. Okay. So how do you know which is a or b? The larger number. So if they were reversed, let's pretend the 1 is here and the 4 is here, right? Then we would still say a is 2, but that's associated with y. Okay, the number underneath the x tells you how much you go left and right, 2. The number underneath the y tells you how much you go up and down, which is 1. So you simply start from the origin and go 2 to the right and 2 to the left. So here are the two vertices. Vertex 1, V1, negative 2, 0. Vertex 2 is 2, 0. Okay. I go up and down only 1 unit. Okay. Remember, if this were a circle, if it's a circle, you go the same distance left and right as up and down. Okay. But because it's an ellipse, it's going to be bulging either horizontally or vertically. So I only go 1 unit up and down. So 0, 1, 0, negative 1. And what names do we give to these? We don't give them any names. Okay, they're not called anything. Okay, and now how to find the foci, F-O-C-I, one focus, two foci. I use the formula a squared equals b squared plus c squared for ellipses. Okay, I want to emphasize again, this is for ellipses, because once we go to the hyperbola, it's a different equation. A is the largest number. Okay, so a squared was 4, b squared was 1. 4 equals 1 plus c squared. Subtract 1. C squared equals 3. So c is the square root of 3. No need for plus or minus. Okay, a, b, and c are all positive. So square root of 3, which is about 1.7. Okay. Now, I put down the 1.7 just so I know where to put the dot. But when you label the points for me, always leave it as exact value. Okay, because technically it's not 1.7. It's approximately 1.7. So when you label the points, write them as radicals. So notice I have F1 as negative radical 3, comma 0, and F2 as positive radical 3, comma 0. Yes, I need to know it's 1.7, so I can tell where it is approximately. That's 1, that's 2, so 1.7 like that, 1.7 like that. Okay, so here are the two foci. Can you say, how do I know where to put the foci? The foci are always along the major axis, never on the minor axis. Okay. Actually, in this case, if you notice, if you go 1.7 up or down, you're not even inside the ellipse anymore. You're outside the curve, so to speak. So there we are. Okay, so here are the two foci. Okay, so that's basically it. So one more time, take the square root of that, 2. That's my A. Square root of that, 1. That's my B. Okay. If the numbers were reversed, if that was a 1 and that was a 4, I would call that one A. But nevertheless, the number underneath the X tells me how much I go left and right. The number underneath the Y tells me how much I go up and down. Okay. Use this formula to figure out the C. Okay. The C is always on the major axis. So 1.7 that way, 1.7 that way. But again, when you label it for me, label them as square roots. So here's focus 1, F1, negative radical 3, 0. Focus 2, F2, radical 3, 0. Vertex 1, V1, negative 2, 0. Vertex 2, 2, 0. The endpoints of the minor axis, which don't have any special names, 0, 1, and 0, negative 1. And there we go. Okay, so that's basically it. All right, then number 3. By the way, let me check something again. Yes, I have figured out how to open the chat even on screen sharing. So if anybody wants to ask a question or put it in the chat, you certainly may. All right, number 3. Again, number 3, it just says x squared. But we know in standard form it has to have x squared over something. So just make it x squared over 1. Okay. So x squared over 1 plus y squared over 9 equals 1. Okay, take the square roots of each of these numbers. Square root of 1, 1. Square root of 9, 3. Okay, our designation for A and B, though, is the larger and smaller numbers. So don't think A is always with X and B is always with Y. Okay, we're going to make it the larger number is A. Okay, so A gets to be 3, B gets to be 1. Okay, so here's our example where it's going to be bulging vertically. Right? The other one was bulging horizontally because the larger number was under the X. So larger number under X, X direction is bulging, which makes sense. Larger number under the Y, so the Y is going to be bigger. And it is. You're going more, in this case, vertically than horizontally. Okay, so let's see. A is 3, B is 1. Use the formula A squared equals B squared plus C squared. Okay, that's true for the ellipse. Okay, so A squared is 9. B squared is 1. 9 equals 1 plus C squared. Subtract 1. 8 is C squared. Square root. C is radical 8. Okay, and we know from algebra, 8 is 4 times 2. Square root of 4 will come outside and become a 2. So 2 radical 2. Okay, so again, that's the exact value, but use your calculator to get a decimal approximation. And the approximate value is 2.8, or the square root of 8. So just for fun, see, 8, square root button, sorry, 2.828, whatever. Okay, so 2.8. So where do I label the foci? Where do I put them? It's always on the major axis. So since it's bulging vertically, it's this way, not left and right this time. So 2.8, well, this is 3, so it's way up there. So 1, 2, 8, 1, 2, 8. But again, when you label it for me, right? When you label it, list the exact values. So vertex 1, 0, 3. V2, vertex 2, 0, negative 3. These are the two foci, F-O-C-I, plural of focus, one focus, two foci. So focus 1, 0, comma. So when you label it for me, don't put 2.8. Put, what was it, 2 radical 2. If you can't read that, that says 0, comma, 2 radical 2. And focus 2, F2, 0, comma, negative 2 radical 2. And the two endpoints of the minor axis are negative 1, 0, and 1, 0. Don't call them anything. Okay. So there we go. All right, now the next problems, 5 and 7, the right-hand side isn't 1. So you have to make it 1. So number 5, divide by 400. Number 7, divide by 6. Okay, I was going to do 7 for you. Even though the numbers are smaller, it's actually worse because the numbers don't come out nice. 5 comes out nice. When you divide by 400, everything's a perfect square. Number 7 doesn't come out to be perfect squares. So I was going to show you 7 and let you do 5 on your own. So 3x squared plus 2y squared equals 6. All right, so from here, the right-hand side is supposed to be 1, so just divide everything by 6. All right, so this becomes 3 over 6 x squared over 2 plus 2 over 6 y squared over 3 equals 1. Okay. So this is larger. So A is the square root of 3, about 1.7. See, not very convenient. B is the square root of 2, also not very convenient. It's about 1.4. All right, so let's see. It's bulging vertically, although not by very much. I mean, 1.7 as opposed to 1.4. Okay, so I actually drew it. You can see it almost looks like a circle. I know it's not a circle, but, you know, it's the difference between 1.7 and 1.4. Okay, it's a little bit. So I go up about 1.7, and I go down about 1.7. And then left and right, I go about 1.4, a little bit less than 1.5, like that. Okay, so vertex 1 is 0, comma, radical 3. My vertex 2 is 0, comma, negative radical 3. Now, let's find my C, which is my focal distance. A squared equals B squared plus C squared. A squared, A is radical 3, right? So A squared is just 3. What's B squared? Well, B is radical 2, so B squared is 2. So C is actually nice. Subtract 2, C squared is 1, so C is 1. So that's nice. So I just go 1 unit. Which direction? It's always along the major axis, so that's up and down. Okay, so if you can't read that, it says focus 1 is 0, comma 1. Focus 2 is 0, comma negative 1. Okay, and we fully analyzed this problem. Okay, so up and down from the origin was radical 3, 1.7. So vertex 1 is 0, comma radical 3. Vertex 2, 0, comma negative radical 3. That says V2 there. Focus 1 and focus 2 are nice. It's just 1 unit up and down. So focus 1 is 0, comma 1. Focus 2 is 0, comma negative 1. The endpoints of the minor axis, which don't have any special name, are, looks like negative radical 2, 0, and radical 2, 0. All right, problem's finished, but again, I'll just give you a little bit more about the words foci and focus. Okay, so if I take any point in an ellipse, the sum of the distances away from the foci is the same. So if I take this point, this distance plus this distance is the same as the distance there plus that, and the same as the distance there plus that, and so on. Okay? And there's also the reflective property of the ellipse, as I said. If you have a ray of light, a ray of sound, or whatever, and if you emit the source of light or sound or whatever from one focus, bounces off, it always runs through the other focus. Okay? In fact, if you just keep doing that, it'll just forever, keep bouncing back and forth and always go through the other focus, as it turns out. Okay. All right, now for harder problems, 11 and on, we're going to have to complete the square. So 9, 11, and 13, we have to complete the square. And furthermore, we're not going to be centered at the origin. So we're going to make it, parentheses x plus 4 squared, or parentheses y minus 3 squared, or something like that. Okay, so how do you do 9, 11, and 13? Okay. So here's 11. We complete the square. Complete the square, you half and square. Okay, x squared plus 4y squared minus 2x minus 16y plus 13 equals 0. What do we do? Right? So we have to force the equation to look the way that we want it to. First thing we're going to do is move over the constant, 13, move the 13 over. So 13 goes over. All right. I know I've already written on this, but look only at the blue stuff. So temporarily ignore any green and any red. Okay, so put the x's together, x squared minus 2x. Okay, I put that x squared with that minus 2x. The 13 moves over as negative 13. Okay, put the y's together, 4y squared minus 16y. Factor out the 4. So if there's any coefficient in front of the y squared or x squared, factor it out. So 4 parentheses y squared minus 4y, right? Double check. What happens if you multiply that out? 4y squared minus 16y. There it is. Okay, so again, temporarily ignore any red or green stuff that I have. X squared minus 2x together. Factor out the 4, y squared minus 4y. And the 13 moves over. Now I complete the square. Half and square, that theme again. Okay, so take half the coefficient of x and square it. So scratch work here. What's 1/2 of negative 2? Negative 1. Negative 1 squared is 1. So I add 1 to both sides in red here. Do the same thing for the y. So half and square. Half the coefficient of y and square it. So what's half of negative 4? Half of negative 4 is negative 2. Square it. Negative 2 squared is 4. So I add 4, but you have to watch out. I'm putting plus 4 here, but because there's a 4 here, I'm really adding 16. So plus 4 here translates to plus 16 on this side. Okay, because there's a 4 here, right, I really added 16 on this side, so I add 16 to that side. Okay. If you want, you can kind of take inventory, so to speak. Let's check with the original. There's the x squared. There's a minus 2x. There's 4y squared. There's minus 16y. I moved the 13 over, so it's negative 13, right? Plus 1 on both sides. Plus 16, if you multiply this out, plus 16, so plus 16. Okay, so that's what I want. Now, factor this as a perfect square. Factor this as a perfect square. Let's get this out of the way. This is negative 13 plus 1 plus 16 is 4, right? Negative 13 plus 1 is negative 12 plus 16 is 4. This factors into x minus 1 squared. This factors into y minus 2 squared. Okay, so that's what I want right now. X minus 1 squared, y minus 2 squared. Okay, this is a 4. I want it to be 1. Divide by 4, divide by 4, divide by 4. And finally, we got it to be the way that we want it. Okay, x minus 1 squared over 4 plus 4 divided by 4 is 1. Y minus 2 squared over 1 is equal to 1. All right, so the center is 1, 2, right? Got translated. 1 to the right, 2 up. So my center is 1, 2. Okay, take the square root of that. Square root of that. We've already seen this, I think. A is 2, B is 1. Okay, C is going to be radical 3. I mean, this is the same as this. Just peek back over here, right? In fact, number 1 and number, whatever this was, number 11, are completely identical. 4, 1, 1, 4, 1, 1. All that's happened is that the center got translated from 0, 0 over to 1, comma 2. So I can just peek over here and copy everything else. Okay, so here we are. Center is 1, 2. C is radical 3. It's the same equation. A squared equals B squared plus C squared. So 4 equals 1 plus C squared. You can just copy and paste all that over there if you want. All right, so let's see, 2 to the left from 1, 2 is negative 1, 2, so that's vertex 1. I go 2 to the right from 1, 2 is 3, 2, so here's vertex 2. I only go 1 unit up and down. So from 1, 2, up 1 is 1, 3, down 1 is 1, 1. No special names. And for the focus, I go again 1.7 that way and that way. The only way you can write the whole thing is to say negative, let's see, negative 1 plus radical 3. So we show up here. Oh, I'm sorry, 1 minus radical 3. Right. That's right, that's 1. I take away radical 3. So 1 minus radical 3 comma 2 is focus 1. And focus 2 is 1 plus radical 3 comma 2. So there we go. So you can see it's a little bit more clumsy when I'm not centered at the origin, okay, in terms of moving stuff and how you write it. But otherwise, it's a pretty much the same concept as before. Okay, so that was 11. Okay, next one I was going to show you is, let's see, 13, because that's a little bit trickier also. So 13, there's a coefficient in front of the x squared and y squared. Each of those are going to have to be factored out. Okay, so let me work out 13 for you. 2x squared plus 4y squared plus 4x minus 16y plus 2 equals 0. Okay, what's all these arrows and stuff? Okay, so move the 2 over, it becomes a negative 2. This means put the x squared with the x with the x, put the y with the y. Okay. So I'm going to put together 2x squared plus 4x, but in the process of doing that, I'm going to factor out the common factor. So what's the common factor for 2x squared and 4x? And by the way, don't take out the x either. Leave the x alone, just the number. So 2. So 2 parentheses x squared plus 2x. And for now, temporarily ignore any red or green. Right. So notice what happens if you multiply this back out. 2x squared plus 4x. You got it, right? Okay, do the same thing for the y's. 4y squared minus 16y. I'm going to take out the 4. Don't take out the 4y, just take out the 4. So it becomes 4 parentheses y squared minus 4y. Is that okay? You can double check, like take inventory. Okay, ignore any red or green. 2x squared, there it is. Plus 4x, there it is. Plus 4y squared, there it is. 4 times a negative 4y, negative 16y, there it is. What about the plus 2? I moved it over, it became a negative 2. So it looks like we're good. Okay, complete the square. Half and square. Take half the coefficient of 2, coefficient of x, which is 2. Half of 2 is 1. 1 squared is 1. So plus 1. But it's not really adding 1 to the left-hand side of the equal sign. Because there's a 2 in front, I'm really adding 2. Right? And same game over here. Do the half and square. Half of negative 4, negative 2. Square it. Negative 2 squared is 4. So plus 4 here, but just like the previous problem, plus 4 here really means plus 16 total because it's being distributed at 4 times the 4. Okay. So the right side's just 16. These cancel out. Okay. This factors into 2 parentheses x plus 1 squared plus 4 parentheses y minus 2 squared equals 16. And there we go. Divide both sides by 16. X plus 1 squared over 8. Y minus 2 squared over 4 equals 1. Okay, so that's the way that we want it. So where's my center? Negative 1, 2. So we translate it 1 to the left, 2 up, so the center is negative 1, 2. Okay, take the square root of each of these. This one's not nice. Square root of 8 is, we did it before though, it's 4 times 2, 2 radical 2, it's about 2.8. Square root of 4 is 2. Use the formula a squared equals b squared plus c squared. A squared is 8. B squared is 4. That's easy. Subtract 4. C squared is 4. So C is 2. That's nice, convenient. All right, so how do I do the graph? I start at negative 1, 2. That's my center. How much do I go left and right? 2.8. So it's not that nice. 1, 2, not quite 3. 1, 2, not quite 3. See, I messed up here. Okay, so how do I write this? Negative 1 plus 2 radical 2, comma 2. And negative 1 minus 2 radical 2, comma 2. So here are my two vertices, vertex 1, vertex 2. How much do I go up and down? B, which is 2. So from negative 1, 2, if I go up 2, it's negative 1, 4. If I go down 2, it's negative 1, 0. No special names. And the foci are always along the major axis, so it's going horizontally. The C came out to be 2. You have to be careful, we have two different C's here. Little c is the focal length, capital C is for the center. It's a point. Okay, so from here I go 2 to the left and 2 to the right. So 2 to the right, focus 2 is 1, comma 2. 2 to the left, focus 1 is negative 3, 2. I guess I should have started with F1, but anyway. So F1 is negative 3, 2. F2 is 1, 2. Center is negative 1, 2. And there we go. Okay. Endpoints of the minor axis, negative 1, 4, negative 1, 0. How come? I go up and down 2 units, which was the B. I go left and right 2 radical 2 units, square root of 8. So negative 1 plus 2 radical 2, comma 2. Negative 1 minus 2 radical 2, comma 2. Okay. So that's that. All right, folks, I was just going to show you one more problem 15, then I'll be done. So after about 2 or 3 minutes, I'll be finished. If you want to ask questions, you may. Otherwise, we're done for today. For the rest of the types of problems, they don't give you the equation. You have to come up with it. So they give you some properties, like they may give you some intercepts or the foci or vertices or whatever. So based on that information, can I come up with the equation of the ellipse? Okay. So I'll just do 15, and I'll stop there. The x-intercepts. Okay, what does x-intercept mean? Y equals 0. What does y-intercept mean? X equals 0. So x-intercepts are plus or minus 4, 0. Y-intercepts 0 plus or minus 3. Okay, so how do I do that? Okay, so x-intercepts plus or minus 4, 0. Y-intercept 0 plus or minus 3. Okay, so here's the graph. So we're centered at the origin. Okay, so how do you know? It's halfway between the two intercepts, or these two intercepts. Right, so A is 4. How do I know A is 4? That's how much I go left and right. B is 3. That's up and down in this particular case. So A is 4, B is 3. I can immediately get the equation. It's x squared over 16, A squared, plus y squared over 9, B squared, equals 1. So there we are. Find the two foci. A squared equals B squared plus C squared. Okay, A squared is 16. B squared is 9. You have to watch out. This is not a 3, 4, 5. Okay. You might be tempted to just say, oh, 3, 4. The next one's automatically 5. No, because A is the largest one. Okay, so that becomes 16. That's 9. So you have to be careful about, automatically assuming 3, 4, 5. So double check. So in fact, it's not nice. Radical 7. All right, subtract 9. C squared is 7. So C is radical 7, which is about 2.6. So I go a little bit more than 2.5. 1, 2.5. 1, 2.5. Okay, so here are my two foci. F1 is negative radical 7, comma 0. F2 is radical 7, 0. That's a 2 there. Can't see very well. All right, so that's it for that one. Okay, folks, so we're done. Let me check the chat. Okay, for problem 13, how do I get the foci? Okay. So the center was negative 1, 2. Okay. The little c was 2. Okay. I know it's bulging horizontally because the number underneath the x was larger than the number underneath the y. So the foci are always along the major axis. So that means I go 2 units left and right. So from negative 1, 2, if I add 2 units to x, it's the same y value, right? It's the same height. So negative 1, 2, I have to move over 1, 2 spaces. It's now 1, 2. And if I go left 2, I was at negative 1, back 1, 2. So now the x coordinate is negative 3, but the y value is still 2, right? So focus 1 is negative 3, comma 2, right? So from here, if I go to the left or to the right, you don't change that vertical height, right? So the y coordinate stays 2. But if I add 2 units to negative 1, I get positive. Or you can just look at the picture, right? I'm at 1, 2 now. And if I go 2 to the left, I'm now at negative 1, 2, 3. So negative 3, comma 2 is where I'm at that stage. Okay. All right. And let's see. I think I've caught up with the chat. Okay. Any questions, please? You can either unmute yourselves or put it in the chat. Otherwise, we're done, folks. All right. I don't hear anything, so that'll do it for today, folks. All right. So tomorrow I'll continue with the ellipse and go on from there. All right. Have a good day, everybody. See you. Bye.